Hello all, let's start section 1.2. In 1.2 we are still kind of working on geometry, not trigonometry yet, but in 1.3 of your book we will start with actual lectures of trigonometry. In 1.2 we are getting more familiar with angles and their relationship. As you see in the topic, 1.2 is talking about angle relationships and similar triangles. This will be an extra geometry kind of lecture that they have it for your book to make you more familiar with angles, because you know when we are talking about trigonometry, it's all about angles. And they want to see that you have a good knowledge of angles first to can deal with uh, trigonometry, correct? The first thing that I want to cover here today is vertical angles. What are vertical angles? If I draw two lines, for example, one of them this, and I'll name 2 points in this line. For example, I'll name here N, I'll name here P, and I draw another line like this, and I'll name 2 points on this line, for example, here Q and here P. These two lines are intersecting each other in one point. Let's name it, for example, point M. Correct? You see these two lines, actually they are forming angles. For example, the first angle that I can see is angle R, this one is R, angle of RMQ. You see, RMQ is an angle. And the second angle that I see is NMP, correct? NMP. What is the relationship between these two angles? These two angles are actually equal to each other. Then I can say, or also, look at these two. Let's talk about these two also. Again, QMN or NMQ, NMQ, and also this angle on this side, which is PMR, right? These two angles are also vertical with each other and they are equal to each other, correct? Now, I can say then vertical angles have equal measures. Remember this. It's really important. You need it in future. Correct? Vertical angles, they have equal measures. They're equal to each other. Correct? RMQ is equal to NMP. NMQ is equal to PMR. Correct? If they are forming a vertical, they are equal to each other. Correct? Now, let's see if I have two parallel lines. Let's write first here parallel lines. If I have two parallel lines, I'll try to draw really good two parallel lines. My hands are shaking as usual because my pen is electronic, and what I have here, I'm working on Wacom, which is a small kind of board, and you cannot kind of control your hand. These two lines, correct? If I name, for example, this line M, and I name this line N, N and M, they are two parallel lines. You see, as much as I continue, as much as I extend these two lines, they are not intersecting each other. Or in an easy English language, they cannot meet each other in one point. It's impossible. And at the same time, you see both of them is on the same plane. Correct? Now, to put a good definition for parallel lines, I can say parallel lines are lines that lies in the same plane and the important part, and do not intersect. Do not intersect. This will be the definition of two parallel lines. Why we are talking about two parallel lines? Look, sometimes another line intersects these two lines. If I draw this red line, correct? I want to name it, for example, Q. Line Q is actually intersecting these two parallel lines in 2 points, correct? Here and here. We call this red line, if a line intersects two parallel lines, we call them transversal. Correct? Line Q is a transversal because it intersects two parallel lines. As soon as it intersects, you see how many angles it's forming right now? Even you can count. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 angles formed here, correct? And definitely they have relation with each other. At least from what I did before with you, look, number 2 and number 3, they are vertical angles. They are equal to each other. Immediately you know that. Number 1 and number 4, they are vertical angles. They are equal to each other. 5 and 8, they are equal. 7 and 6, they are equal because of the same reason, because they are vertical angles. At least you know this much. Now, I'll add more. Let's see what else we can find, correct? First, some names. Angle 5 and 4, angle 4 and 5, and also same way 3 and 6, we call these angles, each pair, correct? Not all of them. Each pair called alternate interior angles. 5, 4 and 5, alternate interior angles. 3 and 6, they are alternate interior angles. What is the rule or what is the relation between two alternate interior angles? They are equal. It means you can say 4 is equal to 5, angle 4 is equal to angle 5, and also angle 3 is equal to angle what? 6. Correct? Now I'll make it smaller to make more space. Maybe I'll move my page this way. Same time, at the same time, angle 8, 1 and 8, and also 2 and 7. We call these angles 1 and 8 or 2 and 7, correct? We call them alternate exterior angles. What is the relation or what is the rule? Alternate exterior angles, their measures are equal. It means 1 is equal to 8 and 2 is equal to 7. This angle, 1 is equal to 8 and 2 is equal to what? Equal to 7. Some more rules. They're really interesting, you see, because you have here 8 angles. There are some more rules. Now, angle 4 and 6. The same way you can talk about 3 and 5. 4 and 6 or 3 and 5. I'll use green color here. 4 or 6, or maybe I'll use blue. 3 and 5. Correct? First, what we call them. 4 and 6 or 3 and 5. We call this one interior angles on a same side, of your transversal, correct? What is the relation? Four plus 6 gives you 180 degree, or 3 plus 5, if you add them, they gives you 180. Look at here in the diagram. If you add 4 plus 6, it gives you 180 degree. If you add 3 with 5, it gives you 180 degree. Another one, last one, another relation. Angle 2 and 6, or you can say 1 and 5, or 3, 7, or 7, 4, 8. All of them is outside, you see. 2 and 6, one outside, one inside, correct? 1 or 5. 1 and 5. One is outside, one is inside, but it's on the same side of transversal, correct? We call these angles corresponding angles. What is the relation or what is the rule, correct? their angle measures are equal, you can say 2 is equal to 6, 1 is equal to 5, 3 is equal to 7, 4 is equal to what? Equal to 8. Let's see it in the diagram. 1, 2 is equal to 6. This angle, if I make it darker, angle 2, is equal to angle 6. Correct? Same way, 1 with 5, 3 with 7, 4 with 8, they are equal to each other. Now, using this rules or this relation, even you can call them rules, we can solve some problems, correct? We can solve some problems using a little bit of algebra, not difficult problems. They are really, really easy as long as you remember all these relations, correct? If you remember these relations, they are not difficult. We can do some problems for you, correct? Example number 1. Find the measures of angles 1, 2, 3, and 4 given that they give you something, of course, given that lines M and N, lines M and M, you have two lines, are parallel or parallel, correct? Now, I'll draw the diagram for you, whatever is given to you in your book or in this example. You have two lines. This one is line M, and you have another line parallel to this. The name is N. We have a transversal intersecting these two lines in 2 points. This is angle 1, this is 2, this is 3, and they name this one 4. They are asking you to find the measures of these angles given these things. For angle 1, they give you here is 3x plus 2 degree. 3x plus 2 degree. This angle, angle 1, is 3x plus 2 degree. Angle 4 is 5x minus 40 degree. Okay, now you know a lot of relations. We just noted. But be careful when you are using relations between these angles, which one works for you? That's important. You see angle 1 and 3, they are right angles, they are equal to each other. If I make an equation like this, 3x plus 2 equals angle 3, it's a name, right? Angle 3. Even you cannot use 3 as a 3 to subtract 2 from both sides because it's the name of the angle. They shouldn't put 1, 2, 3 there. They could use ABC. But if you do this, it doesn't solve any problem for you. It's useless. You cannot solve this equation, correct? Because you have one variable here, x, and the other variable actually is angle 3, correct? It doesn't hurt you at all. Then which relation is good? You see, 1 and 4 is a good relation, 1 with 4. What was the relation between angle 1 and angle 4? They are alternate. They are alternate. Exterior, both of them is exterior. Angles, right? Am I right? Alternate because one of them is on one side of the transversal, the other one is on the other side of transversal. Exterior because both of them is outside, not inside of the parallel lines. Correct? That's why they are alternate exterior angles. What was the relation between angle 1 and 4? Alternate exterior angles. We just study they are equal to each other. Wow, what a good relationship. Then I can write 3x plus 2 equals 5x minus 40. And I can solve this equation. All of you, you can do it. It's very easy, right? Subtract 3x from both sides and also add 40 to both sides if you want to do in one step. And all of you, I'm sure you know this much algebra because you are in a trigonometry class, correct? These two cancels out. 2 plus 40 gives you 42. Equals, these two cancels out. 5x minus 3x gives you 2x. And if you solve for x, you divide both sides by 2. Then your x is equal 42 divided by 2 gives you 21. As soon as I know the value of x, isn't it easy to find the measure of angle 1 in terms of degree? Because I know in terms of x. Look, angle 1, if I use the sign of angle here, angle 1 equals 3x plus 2 degree. It means it's equal that 3 times 21 plus what? Plus 2, which gives you 3 times 21 gives you 63, right? Plus 2 gives you 65. It means your angle 1 is actually how much? 65 degrees. This one is 65 degree. Okay, even without plugging 21 and angle 4, how much should be angle 4? Immediately because of this relationship, even if I don't want to plug in 21 again in this one, 5x minus 40. Why I should work if I know this relation? Immediately I know this one is also 65 degree because they are equal. Okay, if this is 65, this is 65, how much is angle 3 which they are asking? You see, angle 1 and angle 3, they are what? Vertical angles, right? And also, you can say because they are verticals, then 1 is equal to 3, correct? It means your angle 3 is also how much? 65 degree. Now, I want to find angle 1. I know angle 1. I want to find how much is angle 2. Okay, if you remember from my first lecture, if I add 1 and 2, how much I should get? They are supplement to each other, right? Angle 1 and angle 2, they are supplement to each other, or they are supplemental, correct? They are supplemental angles, 1 and 2. It means, supplemental means, if you add angle 1 with angle 2, it should gives you 180 degree. Now I know the value of angle 1, which is 65, plus angle 2 equals 180. And if I solve it for angle 2, I will subtract 65 degree from both sides, correct? Then your angle 2 is equal 115 degrees, correct? You see, using this relationships or rules between angles that I here introduced to you, you can solve different problems. Actually, I did one example, it was equal to like 5 examples, correct? Because we kind of made equal all these angles with each other. We use their relationships. These problems are easy, I told you, as long as you remember the relationship between angles. If you remember that part, solving of them is really easy, or finding the measure is easy. But if you don't remember the relationship, then how to solve it, correct? Of course, it will be, if you do, you will do wrong, correct? I will stop the part 1 of this lecture here. In part 2, in section 1.2, I will talk about angle sum, or the sum of angles in a triangle. Correct? Slowly, we are moving from angles to triangles. The first thing that we want to learn is what is the sum of the angles in a triangle. Correct? And using that relationship, of course, we do some easy examples.